In my last video, I talked a lot about the difference between degrees and radians when we're looking at triangles and angles. So this is really going to come in handy right now because in this video, I'm going to talk about sine and cosine graphs. So how we can take different inputs for our angles and be able to find patterns and use that as an input for an actual function. So in order to do this, we're going to have to become familiar with what's called the unit circle. So the unit circle is just kind of imagining the triangles that we're dealing with on an axis, or on a set of axes like this. So let's just imagine we have a circle right here. So the radius of this circle is going to be 1 unit long. So let's say this was our sine of theta, or sorry, this was our theta, right? This was our x-axis, this was our y-axis like this. Okay, for example, sine theta. Remember, sine of theta is our opposite over hypotenuse in SOHCAHTOA. So if we make this a triangle, we draw a straight line down, make it a right triangle. This is going to be our y value, right, because it corresponds to the y value here. And this is going to be our x value, right? And this is just going to be 1. So our sine of theta is going to be y over 1, because our y is our opposite side to the angle, and our 1 is our hypotenuse, our radius. Okay, tan theta, for example, what would that be? Well, tan theta would be opposite over adjacent, which would be y over x. So whenever the radius is 1, it's really easy to write out the different trig ratios in this form. So right now we're only going to be dealing with sine and cosine, right? So I'm just going to erase this here. Try and keep the circle there. Okay. So we have our unit circle and we have kind of our kind of table here. So I'm only going to be dealing with the main angle 0, which is on this line, right? On the x-axis, pi over 2, which is 90 degrees if we convert it. So it's like a right triangle. Pi radians, which is 180 degrees. And 3 pi over 2 radians, which is 270 degrees. So right now, let's just look at if we had, it's not really a triangle, just kind of a straight line on this x-axis right here. Okay, so right here we have a triangle. It's not really a triangle. It's just like a line, but we can imagine it's a triangle, and our angle is 0 degrees. Okay, so I'm just going to make the pen a bit thicker here so we can see it. So if this is our, it's a bit too thick. If this is our triangle right here, okay, our angle theta, that's going to be 0 degrees. So for our x column here, let's just put 0. So the sine of x, that's going to be the opposite side. So sine of x is going to be the opposite side over the hypotenuse. Now remember, the hypotenuse, if we're on a unit circle, is always going to be 1. So it's going to be something over 1. Now if we have a straight line like this here, our opposite side is going to be 0. Because if we start on the x-axis like this, typically we're going to move our terminal arm up like this, but it's just staying right on this line. So it's not going up or down by anything. So our opposite side is just going to be 0. So when x is 0, the sine of 0 is going to be 0 over 1, which is 0. So the sine of 0, in other words, is just 0. Okay, the sine of 0 is 0, so we're going to put 0 in our table here. So the sine of 0 is 0. Now how about the cosine? Well, cosine of x is the adjacent over the hypotenuse, right? So the cosine of 0, whoops, not theta, cosine of 0 is going to be the adjacent. Well, we have to think about it in a similar way. So if it's laying on this x-axis here, the adjacent side is going to be the exact same as the radius because there's no component rotating it up or down. So if it's on the x-axis, the adjacent side, the x component of it, is going to be the exact same as the radius because everything's going straight to the right. So the entire radius is kind of filling that x component. So the adjacent side is going to be 1 and the hypotenuse side is going to be 1. So this is going to be 1. So the cosine of 0 is 1. Okay, so we kind of have our table filled out a little bit now. We got our first kind of row done. Now that we're done looking at the angle theta equals 0, now let's look at if theta equaled pi over 2. Well, pi over 2 is right here. Okay, so remember this radius is 1. Okay, this radius is 1, and our angle is pi over 2. So if this is our angle theta, well, the sine of theta is over h, and the sine of pi over 2, well, we're just going to think about what the opposite and the hypotenuse are. Remember, the hypotenuse is always 1 because we're on the unit circle. And the opposite side, that's just going to be the height that it gains, right? The height of this thing is the exact same as the radius because kind of like with cosine 0 only going to the right, sine of pi over 2 only goes up. So the whole component of this arrow is going in the vertical direction, so its opposite side is going to be 1. So the sine of pi over 2 is 1. Okay, these are worthwhile numbers to remember. So the sine of pi over 2 is 1, and the cosine, remember, that's how much horizontal component we have. That's the adjacent over the hypotenuse. Okay, so the cosine of theta is a over h. Now the cosine of pi over 2 is going to be, well, it's not going left or right, it's only going up. So the adjacent component is 0. And hypotenuse, that's always going to be 1. Or not 1, sorry, this is going to be 0. So the cosine of pi over 2 is 0. Okay. And I'm just going to change colors here, just so it's a bit more concrete. So I'll make the sine red. Okay, so the sine of 0 was 0. The sine of pi over 2 was 1. Now for cosine, I'll do blue. So the cosine of 0 was 1, and the cosine of pi over 2 was 0. Okay. So now let's move on to pi. Let's do the sine and the cosine of pi. Well, pi is just like 180 degrees, right? It's just this angle right here, kind of like a straight line going to the left. Now, I'll make this a bit thicker here. Okay, so if this is pi, our angle, in standard position, right, the sine is going to be the sine of our angle theta, or x, whatever we call it, is going to be equal to the O over h. Now remember, the O is the vertical component. There's no vertical component here, so it's going to be 0 over 1, which is 0. So the sine of pi, right, the sine of pi, that's going to be equal to 0. Now, how about the cosine? How about the cosine of pi? Well, remember, the cosine is just the adjacent, the horizontal component divided by our radius or hypotenuse. So the cosine, I'll write x instead of theta. That's going to be a over h. The adjacent is going straight to the left. So its entire kind of length of the radius is only going in the horizontal direction, but right now it's going to the left instead of the right. So its adjacent is going to be -1, and the radius is still +1. So the cosine of pi, okay, the cosine of pi is going to be -1. So in blue, I'll just write -1. And we can see kind of the pattern that's going on. It's kind of oscillating to 0, +1, 0, -1. It's just kind of in a different order. It's offset. It's shifted in phase. Okay, and we'll see that once we start to graph it. But it's really important we kind of build this table up before we start graphing, because we're going to see some patterns here. Okay, so now let's look at our last angle here. Let's look at if our angle was 3 pi over 2, right? 270 degrees. So the cosine, or let's do the sine of 3 pi over 2, that's going to be equal to, well, remember, the sine is going to be the vertical component divided by the hypotenuse, or the radius. So the vertical component, it's not going to the left or right, so there's no horizontal component. The vertical component is only going straight down. So all of it, its radius of 1 is all being directed downwards, so it's -1 divided by our hypotenuse, which is +1. So the sine of 3 pi over 2 is going to be -1. So in our column here, I'm going to put when our angle is 3 pi over 2, okay, the sine is -1, and the cosine, well, there's no horizontal component, so the cosine is going to be equal to 0. The cosine of 3 pi over 2 is equal to 0. So I'll just fill that in here. Okay, and now that we have 4 points, this is a decent number of coordinates that we can plot on each graph. So I'll do it on the same set of axes. Let's say we're only doing positive x values. Or I'll have to move this over a bit. So this is positive x values. So this is our x-axis. This is our y. Okay, so we're going to start here at 0. We're going to go to pi over 2. Then we're going to go to pi. Then we're going to go to 3 pi over 2. And notice eventually, right now we're at 3 pi over 2, but if we were to move one more step by 90 degrees to the right, we would just reach 2 pi again. Because 0 is along this x-axis, positive x. If we move 2 pi radians in a circle like this, we just get to where we started, which is kind of, it's called coterminal. It's at the same laying point as we originally started. So 2 pi is kind of the same as 0 in a sense. So remember, the sine of 0 was 0. So if I'm going to plot these points here, let's just do sine first. Sine starts at 0. Okay, the sine of pi over 2 is going to be 1. So it's going to go up here. The sine of pi is 0, so it's going to go back down here. Sine of 3 pi over 2 is -1, so it's going down here. Okay, that's kind of odd. Now, remember how I said that 2 pi and 0 were kind of the same? They were coterminal. So that must mean if they're coterminal, the sine of that angle, 2 pi, should be the same as the sine of 0. So the sine of 2 pi, that's just like the sine of 0 because it's on this line. Right? So it gets back here. And we can imagine, we can kind of infer the shape of this graph is going to look something like this. It's going to go up, come down, reach its maximum, minimum, and then end there. Okay, this is what sine looks like. So it starts at 0. It kind of shifts up to its maximum positive number at +1. I'll write a 1 here. And then its minimum is -1. Its minimum is -1. So this is kind of the maximum point, and this is kind of the minimum point. Okay, and now let's just look at cosine. So the cosine, right, we have our table of values here. The cosine of 0 is going to be 1. So at 0, we're going to start at +1. Okay, we're kind of shifted up from where we started with sine, and the cosine of pi over 2 is 0. So see how they're just kind of shifted in phase here? And now the cosine of pi, remember in our table that was -1, so we're going to be down here. I'm going to make a guess that the cosine of 3 pi over 2 is 0. Yep, looks like it is. So cosine of 3 pi over 2, I'm going to make this a little smaller here. It's going to be right there. Okay, and remember I said that 0 and 2 pi were coterminal, and the cosine of 0 was equal to 1. So that must mean the cosine of 2 pi is equal to 1. So it's going to be up here. So we can kind of connect these dots and see it'll look something like this. Okay, so see how they're both waves, except the cosine, right? The cosine wave is shifted to the left by pi over 2 radians. Okay, so you can get the cosine of something by taking the sine of it and subtracting pi over 2 for your angle. So cosine and sine functions are both continuous, meaning like right now we only went from 0 to 2 pi, but we can go for an infinite number of angles. So I'm not going to start at 0. I'm going to start in positive and negative numbers. So this is our x, this is our y. Now we know that the maximum is 1, the minimum is -1, right? And we know where each of them start. Okay, so we know that sine starts at 0. So it's going to go like this. And I'll draw it a bit higher. Okay, so this is one cycle. But sine keeps going because it's continuous. Right? It's called periodic. It keeps going in the same period. That's what sine looks like. Now cosine starts at 1 and it goes down first. And you'll see how it looks a lot like sine, but it's just shifted to the left by a little bit. Okay, so that's what sine and cosine look like. So I'll write it here, y equals cos x, and y equals sine x. So the red is sine, the blue is cosine. That's the basic idea. So anytime you're looking to graph sine or cosine functions, it's always nice to make a table like we did here. Nice to make a table and pick like 4 or 5 really good points, like 0, pi over 2, pi, 3 pi over 2, 2 pi, 4 pi, multiples of pi or pi over 2 that you can easily graph and make connections with. So sine and cosine, they're the exact same thing, except it's called phase shifted. So see how this one's pi, this is pi over 2, or sorry, this one's pi over 2, this one's pi. They're just shifted by that number of radians, but the shape of the curve is exactly the same thing. So sine and cosine are the same. They're both sinusoids, it's called. I'll write that here, both sinusoids. Okay, except they're shifted in phase. So I'll write that here, write that in the bottom. Shifted in phase by pi over 2 radians. Okay, so that's how we can graph them. And in my next video, I'm going to be talking about the transformations that trigonometric functions can go. So this isn't the only type of sine graph or cosine graph that we can have. We can have it so maybe if we were looking at sine, right? We're looking at the sine graph. Say this was y equals sine x. Y equals 3 sine x, for example. I'll do it in purple. So y equals 3 sine x. This is like y equals sine x, except this 3 in front implies that every point before is being multiplied by 3. So we're still starting at 0 because 3 times 0 is 0. But at our maximum here of 1, right, it's going to be 3 now. So now it's going to be 3. And our minimum point of -1, now that's going to be -3. It's going to be way down here. So y equals 3 sine x. The zeros are still the same, except the maximums and minimums are shifted by a factor of 3 up. Okay, and we can do different phase shifts, different vertical shifts, that kind of stuff. But that's kind of the basic idea with graphing sine and cosine graphs by using tables, using the unit circle, that kind of thing. So I hope it made sense, and I'll see you in my next video talking about trigonometric function transformations. Thanks for listening.